The process will be repeated until we get a line of numbers which are prime to one another. Express all the numbers in terms of prime factors first. The HCF of two numbers is unique positive integer. Suppose if a comma b is equal to d, then d also equal to minus a comma minus b, that is also equal to a comma minus b, that is also equal to minus a comma minus b. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. In my previous class we have discussed regarding the canonical representation of a number and sum of positive divisors and number of positive divisors. Now in this session I am going to teach regarding finding the LCM and HCF of numbers, HCF and LCM of a number, least common multiplier and highest common factor. Now let us come to the first concept, LCM, that is least common multiple, LCM. So you might have been studied this concept in your previous classes itself. How to find the least common multiple, LCM. Now to find the least common multiple, the least number which is exactly divisible by each one of the given number is called the LCM. The least common means which is exactly divisible by each one, that is the least number, the least number which is exactly divisible by each one of the given number. So the least number which exactly divisible by each one of the given number is called their least common multiple, that is called as the least common multiple. Now how to find the least common multiple? So there are certain rules to find the LCM of given numbers. First, there are so many rules. Let me explain the rule number one. In the first rule, to find the LCM of by prime factorization method. So to find the LCM by prime factorization method, that is by factorization method, express each number as the product of primes, then LCM of that number is given by the product of highest power of all the factors. This is very important concept. The LCM can be determined using prime factorization method. In prime factorization method, write down all the numbers as the product of primes. So express each number as the product of prime numbers, then the LCM is equal to product of highest powers. This is very important concept. The product of highest power of all the factors will give the LCM. The highest factors, the product of highest powers of all the factors will give the LCM of the given number. That is known as prime factorization method. Now let me take an example. Now let us take an example. Find the LCM of 12, 21 and 24. Let me take there are different methods to solve this. Let me explain in the easiest method. Now write down the factors of 12 first. So 12 can be written as 4 into 3, that is nothing but 2 square into 3. Okay, next 21 can be written as 3 into 7. Next 24 can be written as 8 into 3. So 8 can be written as 2 cube into 3. Okay, so here this is 3 to the power of 1 into 7 to the power of 1. This is 3 to the power of 1, 3 to the power of 1. So here 12 is equal to 4 3s are 12, that can be written as 2 square. 2 square is 4 into 3, 2 square into 3 to the power of 1. 21 is 3 into 7, 3 power 1 into 7 power 1. And 24 can be written as 8 3s are 24. 8 is nothing but 2 cube, 2 into 2 into 2, 2 to the 4 to the 8, 2 cube into 3 to the power of 1. So these are the prime factors. Okay, express all the numbers in terms of prime factors first. Now, according to the definition, what is the LCM? LCM is nothing but the product of all the highest powers. LCM is equal to the product of all the highest powers. So the highest power of 2 is 2 cube into the highest power of 3 is 3 to the power of 1. 3 into highest power of 7 is 7. So this is 2 cube. 2 cube means 2 to the 4 to the 8 into 7 3s are 21. So this is equal to 21 into 8. That's equal to 8 ones are 8, 8 twos are 16, 168. So therefore, the LCM for this number is 168. So this type of finding the LCM is called a prime factorization method. Okay. Now let us come to a next problem. Find the LCM of the following number by factorization method. That is 36, 40 and 48. Same method. Okay. Now let me simplify this first. So 36 can be written as 2 ones are, 2 eights are, again 2 nines are, we can't divide it, 3 threes are. So 36 can be expressed as 2 square into 3 square. Next, come to the second one. 40 can be expressed as 2 20s are, again 2 10s are, again 2 5s are, 5 ones are. Now we can write 40 is equal to 2 1 2 3 2 cube into 5 to the power of 1. Next number is 48. So 48 can be factorized as 2 2s are, again 2 4s are, again 2 1s are, 2 2s are, again 2 6s are, again 2 3s are, this is 3 1s are. So 48 can be written as 2 to the power of 1 2 3 4, 2 raised to 4 into 3 to the power of 1. Now the factors, what are the factors of 36? 2 square into 3 square. 40, 2 to the power of 3 into 5 to the power of 1. 48, 2 to the power of 4 into 3 to the power of 1. Now just find out the highest powers of all the factors. Now therefore, LCM of 36, 40 and 48 is highest power. So what is the highest power of 2 here? 2 square, 2 cube. So 2 to the power of 4, 2 to the power of 4 into highest power of 3. 3 is, so what is the highest power we have here? 3 square, no 3, 3 to the power of 1, 3 square is the highest power. We can write 3 square. And again, next multiple we have is 5. The highest power of 5 is 5. So that's it. 2 to the power of 4, 3 square into 5. So this can be written as 2 to the power of 4, 2 to the 4, 4 to the 8 to the 16 into 3 square is 9 into 5. So that is nothing but 16 into 9 into 5. 16 into 9 5s are 45. So that's equal to 16 into 45 is 16 45 is 720. 720 is the required answer. That's it. Okay. Now let us come to the next problem. Find the LCM of the following number by factorization method. So 8, 10 and 12. Write down the factors of 8 can be written as 2 4s are, 2 2s are. So 8 is equal to 2 cube. Similarly 10 can be written as, again 2 5s are, 5 1s are. So 10 is equal to 2 to the power of 1 into 5 to the power of 1. So for 10 the factors are 2 power 1 into 5 power 1. Come to the next number 12. 12 can be written as 2 6s are, again 2 3s are, again 3 1s are. So therefore 12 can be written as 2 square into 3 to the power of 1. So 12 is equal to 2 square into 3 to the power of 1. So the highest common. So therefore LCM of, what is the numbers given? X 10 12. The LCM of 8 10 and 12 is equal to, so the highest power of 2 is 2 cube into highest power of 3 is 3 and highest power of 5 is 5. So highest value, highest power of 2 is 2 cube, highest power of 3 is 3 to the power of 1 is 3, 5 is 5 to the power of 1. So this is 2 cube, 2 to the 4, 4 to the 8 into 15. Now simplify this. 15 into 8, 15 8 is 120. So this is equal to 120. That's it. So see here, just factorize this. Factorize 8, 10 and 12. So just find out the highest factors. Highest power of 2 is 2 cube, highest power of 3 is 3 power 1 and 5 is 5. So 8 into 2 cube into 3 into 5, that is 8 into 15, that's equal to 120. That's it. This method of finding the LCM is called by factorization method. Now let us come to the next problem. Let me take one more example. Find the LCM of the following numbers by factorization method. 16, 24 and 20. 16, let us factorize this. 16, 2 8s are 16, 2 4s are, again 2 2s are. So therefore 16 can be written as 2 to the power of 1, 2, 3, 4, 2 to the power of 4. Next, take this number 20. 20 can be factorized as 2 10s are 20, again 2 5s are, again 5 1s are. So therefore the factors of 20 can be written as 2 to the power of 2 square into 5 to the power of 1. Similarly 24 can be written as 2 1s are, 2 2s are, 12 2s are 24, again 2 6s are 12, again 2 3s are, this is 3 1s are. So therefore 24 can be written as 2 to the power of 1 2 3, 2 cube into 3 to the power of 1. Now therefore the factors, the LCM, what are the factors of 16? 2 to the power of 4. Factors of 20, 2 square into 5 to the power of 1. For 24, 2 cube into 3 to the power of 1. So therefore the required LCM of the numbers, LCM is equal to, what is the highest factor of 2? 2 to the power of 4, 2 raised to 4 into highest factor of 3 is 3 into highest factor of 5 is 5. So therefore this is 2 cube, 2 2s are 4, 4 2s are 8 2s are 16, 16 into 15. If you simplify this, this is equal to 240. That's it. Okay. So the LCM of these three numbers is 240. Hope you followed. This is how we are going to find the LCM using factorization method. Now you got an idea how to find the LCM by factorization method. Now let us come to the next concept, that is LCM by division method, rule number 2, second method. Now let me explain the second method. LCM can also be determined using division method. So how to find the LCM by division method? Write the given numbers in an horizontal line. This is usually what we are going to follow. So write the given numbers in an horizontal line, separating them by a commas. Just write down the numbers in an horizontal line and separate them by a comma, right? Then divide by any one of the prime numbers 2, 3, 5 and 7. Divide by any one of the prime numbers like 2, 3, 5 and 7, which will exactly divides at least any two of the numbers. So write down all the numbers in an horizontal line separating by a comma and divide each one. Divide by any one of the prime factors 2, 3. Divide from 2 or 3 or 5 or 7, which will exactly divides at least any two of the factors, any two of the numbers. Write the quotient and undivided number in a line below the first line. So we have to write down the quotient as well as an undivided number in the line below the first line. Then the process will be repeated. The process will be repeated until we get a line numbers which are prime to one another. The process will be repeated until we get a line of numbers which are prime to one another. Then the product of all the divisors and the numbers on the least line will give the required LCM. The product of all the divisors and the numbers in the last line, will give the required LCM of the given number. This is very important concept. Let me explain by taking an example. Let us take an example. Find the LCM of 12, 18 and 24. So what is the rule first? First write down the numbers 12, 18, 24 in a line separated by the commas and divide by any number like 2, 3, 5 and 7. Let us divide by 2. 2 6 are, 2 9s are, 2 12s are. Again, if it is possible to divide by 2, divide it. 2 into 3s are, this 9 is not divisible, and we can divide 2 12 by 6 times. So again we cannot take 2. Let us go to 3. 3 1s are, 3 3s are, 3 2s are. You just stop here. So therefore the LCM is LCM of the numbers 12, 18 and 24 can be as 2 into 2 into 3, 2 into 2 into 3 into 1 into 3 into 2, 1 into 3 into 2. Multiply this. 2 2s are 4, 4 3s are 12 into 3 2s are 6. That's it. 12 into 6, that's equal to 72. 72 is the required LCM for the given numbers. Okay, listen to me, this is very simple and very easiest concept. Write down all the elements, given numbers in first line separated by the commas 12, 18 and 24. Then just divide using the numbers like 2, 3, 5 and 7 prime numbers. 2 from 2, let us start with 2. 2 6 are 12, 2 9s are 18, 2 12s are 24. Again check whether it is divisible by 2 or not. So 2 6 are, 9 is not divisible, keep as it is. 2 12s are 24. Again So this 3, 9 and 6 is not divisible by 2. Let us take 3 from 3. 3 ones are 3, 3 threes are 9, 3 twos are 6. So yeah, just multiply these numbers. 2 into 2 into 3 into 1 into 3 into 2 will give the value. Therefore, the LCM of 12 into 18 into 24 is 12 into 6, that's equal to 72. Now let me take one more example. Find the LCM of the following numbers by division method. Okay. So that is, let us write down the numbers 48, 96 and 72 in a line. Divide from, take 2, from 2, let us check. 2 2s are, 2 4s are, again 2 4s are 8, 16 2 8s are, 2 8s are 16, again 2 3s are 6 and 12 is the remainder, 2 6 are 12. So 24, 48 and 36. Again divide by 2. 2 1s are, 2 2s are, 2 2s are, 2 4s are, again 2 1s are 2, 16 is there, 2 8s are 16. Okay, 12, 24 and 18. Again divide by 2. If we divide by 2, 2 6 are 12, 2 1s are, 2 2s are, again 2 9s are 18. So 6, 12 and 9. Check whether it is possible to divide by 2 or not. Yes, we can divide. 2 3s are 6, again 2 6 are 12 and 9 as it is. Now from 2, we cannot divide from 2, we can take 3 from 3, 3 1s are, 3 2s are, 3 3s are. Okay, that's it. Now therefore, the LCM of the given number, LCM of the numbers, that is 48, 96, 72 is equal to, just multiply it, 2 into 2 into 2 into 2, 2 into 2 into 2 into 2 into 2 into 3 into 1 into 2 into 3. That's all. Multiply this. See here, 2 2s are 4, 4 2s are 8 2s are 16, 16 into 3, 2 2s are 4, 4 2s are 8 2s are 16 into, so 3 2s are 6, 6 3s are 18, 16 into 18. Just multiply this, that's it. If you simplify this, you are going to get it as 288. That's it. 288 is the LCM of 48, 96 and 72. Hope you followed. So the answer for this 288 is the correct answer. Okay, let's come to the next problem. Find the LCM of the following numbers by division method. Now write down the numbers 30, 60 and 90. Let us divide from 2. So 15s are, again 30 times and 45 times. So that is 15 2s are 30, 30 into 2 is 60, 45 into 2 is 90. Right, now we cannot divide from 2. Let us divide from 3. 3 5s are 15, 3 10s are 30, again 3 1s are 3, 15 is there, 5 3s are 15, 15 3s are 45. Again we can divide from 5, okay, 5 1s are, 5 2s are, 5 3s are, and we cannot divide. So therefore the factors LCM of the given numbers is 2 into 3 into 5 into 1 into 2 into 3. So this is 5 3s are 15, 2s are 30 into 3 2s are 6, 6 3s are 18. 180 is the required answer. That's it. So the LCM of the given number is 180. Very simple. See here, 30, 60, 90 write in a first line and divide from 2. Just the factors are 2 15s are, 2 30s are 45. Again divide from 3. 3 5s are 15, 3 10s are 30, 3 15s are 45. Again from 5, 5 1s are, 5 2s are, 5 3s are. 2 into 3 into 5, 2 3s are 6, 6 5s are 30, 30 into 3 2s are 6, 30 into 6 is 180 is the required LCM. Hope you followed. This is how we are going to find the LCM by division method. Now let us take one more problem. Find the LCM of the numbers by division methods 4, 12 and 24. Let us start with 2. 2 2s are, 2 6s are, 2 12s are. Again you can start with 2. 2 1s are, 2 3s are, 2 6 are 12. Again you can start with 3. 3 1s are, 3 2s are. So therefore the required LCM for the number LCM is equal to 2 into 2 into 3 into 1 into 1 into 2. So that is equal to 2 2s are 4, 4 3s are 12 into 2 1s are 2, 12 2s are 24. The required LCM is equal to 24. That's it. Hope you followed. Now let us come to the next problem. Now let us take the statement problem. There are three scales. 3 scales are 65 centimeters, 85 centimeters and 95 centimeters in length. So there are 3 scales of length 65 centimeters, 85 centimeters and 95 centimeters in length. What is the length of the cloth? length of the cloth that can be measured exact number of times using any one of these three scales. So there are three scales. We are going to measure the length of the cloth that can be measured exact number of times using any one of these three scales. Now we have to find out the LCM, that's all. The LCM of these three numbers will give us the required answer. Now find out the LCM for this. So the LCM of 65, 85 and 95 will give us the required answer. So that's equal to, write down the number 65, 85 and 95. We can't divide from 2, 3. Let us go to 5. 5 ones are 5 threes are 15. Again 5 ones are 5, and what is remainder is 7, 3, 5 sevens are 35. Again 5 ones are 5, 45. So 5 nines are 45. So the factors are 13, 17 and 19. Now here we cannot take any number. So we can take 13. 13 ones are this 17, 19 as it is. Again 17, this is 1. 17 ones are, this is 19. Again from 19, so 1, 1 and 1. So therefore the LCM of the numbers is equal to, LCM is 5 into 13 into 17 into 19. So if you multiply, the answer you are going to get is 20995 centimeters. This is the required answer. So the LCM of the scales is 20,995 centimeters. So this is how we are going to calculate the LCM. Now let us come to the next concept. Now let us find out the highest common factor. Now how to find, so far we have discussed regarding LCM, least common multiplier. Now let us find out the HCF, highest common factor or greatest common divisor, that is GCD, or it is also called as the greatest common measure, HCF, highest common factor, HCF, or GCD, greatest common divisor or greatest common measure. So what is the definition? An integer D is called as the greatest common divisor or highest common factor of two integers A and B if both of them are not zeros, if the divisor will divide A and B, if D divides A and D divides B. An integer D is called the greatest common factor or highest common factor of two integers A and B, both of them are not zeros. Then if the divisor will divide both the integers A and B, if D divides A and D divides B, every common divisors of A and B are divisible by D. That is, if X is the common divisor, X will divide A and X divides B, implies X also divides D. That is, every common divisor of A and B divides D. That is, X divides A and X divides B implies X also divides D. So usually the GCD of A and B is denoted by GCD, the greatest common factor or greatest common divisor of A and B is D, or the highest common factor of A and B is equal to D. Now let us take for example, let us consider the highest common factor of 8 and 16 is 8. So the common factor of 8 and 16 is denoted as 8 comma 16 is equal to 8. See the factors of 8, let us write the factors of 8. 8 can be divisible by 2 and 4 and 8. Then 16 can be divisible by 2, again 2, 4, 8 and 16. So 16 by 2, 16 by 4, again 8 2s are 16, 16 1s are 16. So in these two, which is highest common factor, 8 is highest common factor. So therefore the HCF of these two numbers is 8. So the HCF of 8 and 16 is 8, and it is denoted as 8 comma 16 is equal to 8. Suppose HCF of two numbers is unique positive integer. The HCF of two numbers is unique positive integer. Suppose if A comma B is equal to D, then D also equal to minus A comma minus B, that is also equal to A comma minus B, that is also equal to minus A comma minus B. A is a positive integer. Suppose if A comma B is equal to D, then the divisor of minus A and B is same, the divisor of A and minus B is also same, minus A comma minus B is also equal to A, where A is a positive integer. Now, so rules to find the highest common factor are GCD. How to find the GCD? Now, by prime factorization method. The first method is the prime factorization method. express each number as the product of the primes, then HCF is equal to product of least powers of the common factor. This is very important. How to find the highest common factor HCF? Just express each number as the product of prime numbers, prime, then HCF is equal to product of least powers of the common factor, least power of the common factors. Now let us take an example. Find the HCF of 12, 15 and 18. Write down 12, 15 and 18. The factors of 12, 2 6 are, 2 3s are. So 12 can be written as, the factors of 12 are 2 square into 3 to the power of 1. Similarly for 15, 15 can be written as 3 5s are 15. So the factors of 15 are 3 to the power of 1 into 5 to the power of 1. And similarly for 18, write down the factors for 18. 2 9s are, again 3 3s are. So 18 can be written as 2 to the power of 1 into 3 square. These are the factors of 12, 15 and 18, right? That is 12. How to write 12 factors? The factors of 12 are, 12 is equal to 2 cube into 3 to the power of 1. Factors of 15, what are the 15 factors? 3 to the power of 1 into 5 to the power of 1. And the factors of 18, 18 can be written as 2 to the power of 1 into 3 square. Okay. Now find out the common in this. What are the common factor in this? This 3 is the common factor. So what is the least power in this? 3 to the power of 2. So the HCF is equal to 3. The least common, all the common factors are 3 are the common factors, in which the least factor is 3. 3 power 1 is the least, so therefore the highest common factor is equal to 3. So that means 3 will divide 12, 3 divides 15 and also 3 divides 18. Okay. This is how we are going to find the HCF, highest common factor of the numbers, by factorization method. Let me take one more problem. Find the HCF of the following by prime factorization method. Now let us express this. Write on 60, 60. You can start with 2 30s, again 2 15s. This is equal to 3 5s. So the factors of 60 are 2 square into 3 to the power of 1 into 5 to the power of 1. Similarly for 72, I don't write 72 here. 2 3s, 2 6s 12. Again 2 1s 2, 2 8s 16. Again 2 9s. Again this came as 3 3s. So therefore the factors of 72, 72 is equal to 2 to the power of 1 2 3, 2 cube into 3 square. And come to the last one, 84. The factors of 84, 84 can be written as 2 4s, 2 2s, again 2 2s, 2 1s. Again you cannot divide 21 by 2, 3 7s, 21. So therefore the factors are 2 square into 3 to the power of 1 into 7 to the power of 1. Now find out the common in this. The common factors. Common are, what are the common? 2, 2 and 2 is the common. Here 3 is also common. Okay, right. So 7 is not common here, 5 is also not common. The least common, the least value of 2 is 2 square into the least value of 3 is 3 to the power of 1. So this is 4 into 3, that's equal to 12 is the highest common factor. So see here, the common factors are 2 to the power 2 is and 3 are the common factors, in which the least one is 2 square is the least and 3 to the power of 1 is the common. So therefore the highest common factors are 4 into 3 is equal to 12. That's it. So the HCF of 60, 72 and 84 is 12. So that's all regarding today's session. Let us meet with the different concepts in the next session. Thank you very much.